And he'll be addressing changes in international operations during the design phase. Human error is always a big part of issues and downtime in critical facilities. And he'll talk about, having a robust operations and maintenance plan. Thank you, Terry.
Thank you, Mike. I can see everybody's still awake from after lunch, so that's a good thing. Thank you for having me here today. I was talking with Fred Corey a minute ago, and he told me that actually I'm probably late starting this operations planning during design. I should be in pre-design. So that being said, let me move forward. Just a little bit about myself. I've spent the last 30 years in the mechanical, electrical, plumbing, telecommunications side, security side of the industry, predominantly in mission-critical facilities, pharmaceutical, and healthcare. There we go. When I was putting this presentation together, I started to think about some of the clients that we have worked with over the years and clients that are very, very successful at deploying operations and maintenance programs globally as well as data centers. And I wanted to, the theme that came to me was, irregardless of the mission of the facility, the process is probably the same. So whether you are an IBM with Global Technology Corporation, Bank of America, a global financial institution, Facebook, it's hard to believe how the social networking has exploded, but we just commissioned a data center for them up in Luleå, Sweden, or the U.S. government on the Department of Defense and command and control facilities, or the intelligence community and command and control. The common theme is that all of these folks think domestically. They do all of their planning, all of their engineering, all of their operations and maintenance planning locally, and then they try and take that program out to their facilities in global locations. There are probably, as I looked at this, there are probably 4 legs on the chair that are most germane to try and ensure that your operations and maintenance programs will be successful. And if you think about the challenges, anybody in this room have a portfolio of data centers domestically? All right, so when you think about the challenges that you have in trying to have documentation that's consistent between your data center, whether it's in Virginia on the East Coast, or out in LA on the West Coast, or in Dallas, Texas, think about the challenges you face just making sure that your documentation is consistent from facility to facility, and that your operations plans and programs are consistent from facility to facility, and that your maintenance programs and equipment suites are consistent. Think about the challenges that you face doing that domestically, and then multiply that times 10 when you start to take those elements and deploy them globally. So what I'm going to talk about today are some of the things that I think you can do during the planning and design cycle, during commissioning, which is really the validation of the facility, during the transition to operations of the facility, and then what do you do from an ongoing perspective, the audits that most people put in place, both from an operational and from an MEP standpoint, to make sure that the facilities are still operating at their peak performance and are still consistent with the way they were deployed day one. So some of the things that our global clients do is they put together a set of project implementation guidelines, and those typically will cover design, construction, commissioning, then operations and maintenance. And then those guidelines are then adapted to different geographic regions around the world. So you look at the big footprints, you've got North America, Canada, the US, Latin America, South America. Dax talked about some of the challenges that he faced in Mexico, and everyone being a liar. we look at, and so you need to adapt those guidelines regionally, whether it's the EMAU, Europe, Middle East, Africa, Asia Pacific. And then you need to take those guidelines out and not only encourage collaboration of all the stakeholders, and I'm going to stress this today, typically the silos when you deployed a data center were the IT, who took the facility over, the operations folks and the maintenance folks, standalone group, and then the engineering design guys who put the whole thing over and turned it over ultimately to the operations folks who ran it for the IT client. And then you need to incorporate all of those planning elements into the overall project life cycle, starting as early as possible in the project. And again, I stress that as you go out to different geographic regions around the world, your challenges are exacerbated and become more and more difficult as you expand your footprint. So we're going to talk a little bit just the path. Typical project, you'll go through design, you'll go through construction. Now, you know, you don't want to take construction for granted. It's a challenge to build facilities in the U.S., but how do you maintain that same quality if you're building in Central or South America, or in Canada, or in China, or somewhere in the Asia Pacific region? Commissioning, which has become a fairly, well, it's become an element of the project life cycle, just like architecture, engineering, commissioning. It's part of the project life cycle now. And then the transitional period. What I call the transitional period is the year from the day the keys are turned over and you say, okay, I've got it. And then the first year of operations, when you're phasing your new loads in, you're getting your operators up to speed, you're making adjustments, you're doing training. There are a lot of things that happen in that first year. Review of your warranties prior to expiration. There's seasonal testing that has to occur. So there are a lot of things that happen in that first year of operation. And I think there are a lot of things that you can do up in the design phase to ease some of that. And then you have to operate the facility. And one of the things that people overlook is that items 1, 2, 3, and 4 in a typical mission critical deployment, even if you're rushed to market, it's a 9-month project, a year or a year and a half that you'll do your design, your construction, your commissioning, and your transition. But the facility's operated for 30 years. So what happens in that first year or 18 months is going to determine the overall success of that facility operating for its entire life cycle. So let's talk about some of the planning and design elements that are critical, and these are fairly common to projects domestically, but even more important when you go out and try and do a project globally. So the first thing that's typically done is development of a statement of requirements. Now, I know this is IDG's conference, so I don't want to get out of my comfort zone as far as architecture planning goes, but you certainly want to develop a statement on what the project intent is, where is that project located, what is the type of space, is it a call center, is it a data center, command and control center, what's the general size, and that's white space, and then again, the spaces that are required to support the MEP elements. Sometimes the MEP spaces may be a larger element than the white space. What is my load density? And that's what's day one. And then when you look into your crystal ball, where your load's going to be at 3 years, 5 years, 15 years at the end of life of your first cycle of equipment. What are your HVAC requirements? Let's look at HVAC. If you're doing a project in Beijing where the air quality is absolutely abysmal, you typically wouldn't deploy an airside economizer system because you're trying to keep that caustic air outside the building. When you look at your electrical requirements domestically, it's pretty straightforward. Your 480 volt distribution typically. But when you go over to Europe, are you 600 volt? Are you a 400 volt system? What's your incoming service voltage? And then, your building automation system and your electrical power management systems, which are really the heartbeat of the facility, all of your automation elements. How are you going to approach those, and how are you going to deploy those globally? Security requirements. I was touched by the similarities of the challenges that the folks that spoke earlier about security, because they go through the same challenges deploying a security system globally, more so than we do in the U.S. What seismic requirements, and then elevation. And I kind of chuckle. I want to keep saying attitude adjustments instead of altitude adjustments, but what's required there. And then what are the plans for facility expansion? And then what's the end of life planning for equipment? If you build a facility that's got a 30-year life, but your equipment has a 15-year life cycle, how do you accommodate those changes in the equipment as they move down the road? And then once that statement of requirement is developed, then you take that and put meat on the bone. This is typically where the statement of work is put together. The basis of design is developed, which talks about all of the architectural, mechanical, electrical, controls elements in significant detail. What are your goals from a data center efficiency standpoint? PUE seems to be the common approach on measurement for that these days. Are you trying to get a 1.4 or a 1.2? What are your environmental considerations? Obviously, is there a lead sustainable design element? Your environmental goals in Sao Paulo or Beijing, certainly the environmental requirements there are nowhere near as significant as they are in the US, but how are you going to approach those things? And then acceptance testing. I think that your acceptance testing and your commissioning elements should become part of that statement of work up front, because certainly from an acceptance and testing standpoint, how are you going to approach these things with a partner in a foreign country? And then again, when we talk about network operations, if you have a global portfolio, are you going to have your network operations center in your facility that's in Brussels, or is that facility going to report back to a main network operations center here somewhere in the United States where you have 24/7 coverage? Again, talk about your building automation systems and some of the approaches there. I listed DDC, PLC, and hybrid, and I'll speak to that, but in many of the data centers today, direct digital control systems, DDC systems, are used for the less complex elements of the building, but you may use a PLC system to run a mechanical plant. And you may have both of these types of systems within your facility, so that becomes a hybrid, because what type of front end are you going to have on that control system? What are your tenant considerations? Is this going to be a single-purposed facility, or is it going to be a co-location facility with multiple tenants? Again, we have an attitude adjustment at this point in the planning. And then there's some elements here that I listed that I really think need to be part of that statement of work. Short circuit and coordination study. Sometimes that's developed by the engineer of record. Sometimes that short circuit and coordination study is a product of the vendor, whether that's Emerson Network Power or Liebert. What are your operational safety requirements in that facility? And then I want you to think about incorporating all of your operations requirements and all of your maintenance requirements in this statement of work. And the reason I say that is you have to be able to look down the project life cycle, down the design cycle, and have enough time to be able to coordinate who your vendors are and who your support people will be, as you bring this facility on during that transitional period, that first year of operations. Certainly you should have it figured out well before you enter into construction. The other thing that I put in here is nomenclature. So, you know, it's hard enough sometimes to be able to take the information off a single line drawing in the US and make sure that all of your user interface panels and the panels on your switchgear that the language matches. But if you're going to China, are you going to use Chinese language in all of that equipment? Are you going to use a foreign language for all of your labeling, your valve tags? Certainly color coding, color is color. And then again, we fall back to security requirements. So in this segment, so we kind of talked about the planning and design. I'm going to skip over construction because, you know, we recognize that you're going to get a good constructor and they're going to put the program together. But commissioning is really your first opportunity to validate whether this system is going to work the way that you want. So what I did here was I took ASHRAE's description of commissioning. The commissioning process is a quality-oriented process for achieving, verifying, documenting that the performance of the facility and systems and assemblies meet the defined objectives and criteria. And that's where the ASHRAE definition stops. I've added this sentence at the end that says that the commissioning process should also validate all of your operation and maintenance objectives, because during commissioning you have a wonderful opportunity. It's the last time you can operate the facility with no risk to the load, right? Once you put a critical load in that facility, you can no longer use it as a training platform for your operating engineers, for instance. So the other thought, and some of the things that lessons learned certainly for me, is what we envision as commissioning in the United States is not what people may envision as commissioning in foreign countries. So what I want to do is walk through this and emphasize that even when we go to Canada, it's not part of the United States. So they don't view commissioning in Canada the same way we do here. So a lot of the countries that we're working in are where we may have been at the year 2000, introducing commissioning here in the US. It's had 10, 12, 15 years to mature as part of the program. When you get into a foreign country, you're starting all over again. So I think that you have to look at what the benefits are of commissioning. Obviously, it's a validation of the facility at operating at maximum design loads. It certainly gives you increased reliability in the operation of the data center. It's an opportunity to test the equipment, and hopefully that will extend the useful life of the equipment. But again, I'm going to go back to this is an unparalleled opportunity to train your operators. Improved energy savings, and again, I'm going to talk about optimization of your operations and maintenance strategies that you did during planning. You can prove these things out and validate a lot of this during commissioning with no risk to the load. And then hopefully we'll reduce outages due to incorrectly designed elements. Obviously, your commissioning agent is working in conjunction with your architect and engineer, so the peer review process, you'd be able to vet single points of failures and other elements. And then again, I talk about an opportunity to validate your maintenance routines and configurations. As you look at today's data centers, they're built for fault tolerance and concurrent maintenance. So that concurrent maintenance element, you've got to train your operations folks and your maintenance folks on all of those switching procedures, which are fairly complex. And so they need to be as detailed as your standard operating procedures and failure scenarios, et cetera. And then one of the things that I've learned recently, let's talk about what commissioning is not. Because when you go over to a lot of foreign countries, what they consider commissioning to be the manufacturer's startup and checkout. Well, it's not. And it's not testing of the systems by the design engineer, because that doesn't meet your third-party independent spirit. It's not testing of the systems by the installation contractors. It's not testing without predefined and agreed upon acceptance criteria, right? What are the criteria for this facility? And then it's not testing systems without a detailed commissioning plan and detailed procedures that have been accepted in collaboration with the entire ownership and design team. And what I've found is when we get out into a lot of the foreign countries, these are the things that they still view as commissioning. When you go in and you say, where are my guidelines, there is not a single commissioning standard, unlike the NFPA, where you can go to the NFPA and it's pretty much the Bible. Commissioning has a lot of guidelines that people try to address. So ASHRAE is a very good source. The AABC, there's another similar, which is NEBB. These are two industry groups that came up from the testing and balancing industry. You'll find them a lot on the federal side, so they were driving that up from the T&B side. The Building Commissioning Association is fairly widely recognized in the U.S. and starting to get global acceptance. They also have a very good training program in conjunction with the University of Wisconsin. We talk about LEED. If you go to our neighbor in the north, they put a C in front of that, and it's Canadian LEED. We've got green globes and other elements, so it's not as straightforward when you get into the global arena. And then NEDA testing, right? NEDA testing is widely accepted here as the prerequisite and handover for facilities. Well, you may not be able to find NEDA testing. So what's your strategy to go out and procure that service in a foreign country? Are you going to bring your NEDA testing company in from the U.S., or are you going to find a global partner who can perform that service? And then the ASTM International also has some pretty good commissioning guidelines for reference. When you look at commissioning here, it's fairly widely accepted. I put a list of all of the equipment and systems electrically that are usually part of that. And again, I want to emphasize this because I think you need to really lay that out as part of your requirements as you address the commissioning program in a foreign country. So, you know, those are all your major electrical systems. Obviously, this EPO system, you'll only want to test it once and never touch the button again, or you use your UPS to rewrite your resume. And then, you know, on the mechanical side, you've got to look at your fuel oil and delivery systems, all of the mechanical systems. And this is another big one here, plumbing systems, which is certainly becoming an element within the U.S. But when you go to a foreign country, your domestic water service, we had one of the panels talking about the water quality over in India, for instance, right? So what's your domestic water supply? How are you going to filter it? Boilers and other systems that you need to support the facility. And then, again, we come back to controls, right? And what's your approach? How are you going to deploy these systems? But it's amazing when you say, well, we're going to commission MEP systems, and then you do your bid leveling, and somebody says, yeah, but they didn't include the generators, right? And you know, and you go, well, why? Well, it wasn't in the list, right? So, you know, you have to be very, very succinct in defining what systems you want to commission. The other thing that I want to talk about is when you look at your overall typical project structure, where you have your owner, your AE team, your construction manager, and your commissioning authority are usually direct reports to the owner. And I've put O&M validation over here under the commissioning authority because I think that's an area where you can certainly leverage that group to validate all of your operations and maintenance procedures during commissioning. One of the things I want to talk about when you go out globally is you may not be able to find NEDA testing. We've done a couple projects in Canada, and I couldn't find a certified NETA testing firm in Canada, right? So people had to come up from the US to do this work. So I think it's incumbent upon us. These guys also have a third-party independent charter, like the commissioning agent. So you may want to bring these folks and your equipment vendors up here and have them as part of this planning process so that you can tailor your NETA testing, your acceptance testing, and some of your ongoing maintenance as part of that program planning, so you can get out in front of these elements and don't struggle to find these things. And how are you going to do your service and your maintenance? Are there folks in country where you are you going to try and do that with the people that you bought your equipment from? When we talk about full life cycle commissioning, what we typically talk about here in the US is that program starts at the pre-design and programming phase. It moves through the design phase, through the construction phase, up through the acceptance phase, and out to post-occupancy. But one of the things that I want to stress is that I think that a lot of your operational elements, the development of your maintenance operations procedures, your standard operating procedures, your O&M review and coordination, these elements should be completely planned and vetted here at the end of the design phase and validated and incorporated into the construction phase and have been fully vetted during the acceptance phase. In most cases today, we'll write a considerable number of operations, maintenance, failover operating procedures during the documentation phase. And then we validate those operations and maintenance procedures in front of the gear with the operations team. Now that means that you've got to bring some operations folks on board before you get out here, but I think that would be prudent. But even if you don't have the funds or the capital, then bring a small number of folks in and train the trainer. But I think that to be able to train your operating engineers on all of your standard operating procedures, your maintenance procedures, just look from a maintenance standpoint when you look at a UPS system. A typical, in an enterprise class data center today, 100,000 square foot data center, you may have an A and B 3,000 kVA UPS system. It's 4 modules. You may have a catcher system where you have an A, B, and C system that share a common load bank, right? So they'll have a global wrap. Well, it's a fairly complex switching procedure to take a UPS, a 3,000 kVA, 4 or 5 module UPS system offline without dropping the load and put it on maintenance and connect it to the load bank system. Well, you certainly don't want to train your operators to do that while you're carrying live load, right? There's significant risk. And I think you find the same thing if you have an N+2 generator system and you have 1 generator down, so now you're N+1, and you have a utility failure. Do you want to start to train your maintenance guys on how you're going to address this during the utility failure? So again, I'm going to stress that if those things are developed here, which is even if you do a starter kit, 10 electrical, 10 mechanical, and some controls and some failure scenarios, have a starter kit that you can turn over during the transitional period. And the other thing that I want to talk about is these are the typical 5 levels of testing that occur during commissioning. But the first 3, the factory acceptance, the site arrival inspection, and the startup and acceptance testing, those three elements are defined per the plans and specs, and they are part of the bid package. So if you do not incorporate your operations and maintenance elements into the bid package, when we get up here to do the functional performance testing, it's too late. You either have to add it in or react and try and get those elements incorporated. So again, this goes back to the planning and design phase. Get as much of that specified and bid so that's in the plans and specs. This goes back, and I kind of like this, one of our guys coined this, but commission, transition, and sustain. So the commissioning we talked about, this is where you're going to validate the facility. This transitional period here is the first year. Well, this is where everybody's getting accustomed to the standard operating procedures, the maintenance procedures. You've got a lot of training going on. So that period of time is critical to the operations of the facility. And then we go back out here again, you want to sustain that high level of ongoing operations, and that can be as long as 25 or 30 years. So let's look a little bit about operations and maintenance. This is going to go back to some of the points that I was making before, but I think you really need to include the O&M considerations in the programming phase. So whatever you have to do within your organization to bring those silos together and collaborate, especially if you're going to deploy facilities globally, I think that you need to be able to do that. You've got to build and define what that O&M organization is and what the reporting structure and the budget is. Training. This goes back again to my earlier point that you can get a significant amount of operations and maintenance training done during functional and integrated systems prior to going to operational. But you really need to put a training program together that addresses where you're going to be day one. Because as you all know, you deploy data centers. Typically, they're phased construction on large data centers, whether you're adding 20,000 or 25,000 increments of space, whether you're adding pods, right, within an existing shell. Your requirements for your day one loads and your day one controls are different than what you're going to do 1 year from day one and beyond. So you really have to have a training program that looks at your day one requirements, and then how do you train new hires, and then what's the recurring training that has to occur to keep your operations and maintenance staff sharp and up to speed. You need to define what your O&M program and processes are. What spaces do you need? One of the things that we typically hear is I don't have enough storage for my spare parts, I don't have enough storage or room to set up my equipment. So you want to get your offices, your command centers, your shops, your storage, all of those things defined during programming and design. Then those elements are included in the facility and you're not struggling for space. O&M manuals. O&M manuals over the years have been fairly typical. If you are the equipment vendor is going to send an O&M manual that's for the cracks, and you're going to get another one for the generators. And I'm not picking on the generator guys, but if you have some 2 meg engines, well, you may get all the engines that sit in that engine group. There may be 5 or 6 different models in that O&M magazine. What I'm advocating is that this is always part of the bid, and it's always purchased as part of the bid set. But I think you have an opportunity to define specifically how you want your O&Ms to be laid out. So a lot of our clients today will put together the O&M narrative so that whether you get an operations manual for a UPS system or a generator or a crack or a chiller, they all have the same sections and elements, the same touch and a feel. And if a section of that O&M manual doesn't apply, then you say just this section left intentionally blank. But so that O&M manual has a descriptive narrative of the equipment. It contains the single lines, all the sequences of operations, the set points, all of your operating procedures, go back to those. All of your submittals, so when someone looks at a piece of equipment and they go, what did we get, right? That has all the approved submittal has all the parts and appurtenances that would come with a piece of equipment. Your spare parts lists, the warranties. In many cases, we'll include the training in the O&M manual so that when you bring the person on board, you can pull the CD out and run them through the training. So I think that you have a great opportunity to define specifically what your O&M manuals are and get them generated specifically for your facility because you've bought that as part of your bid package. Training. I think that if we look at, if we all agree that commissioning has driven the majority of failures out of the facilities, then I've heard numbers, and I think are fairly accurate, that 74% of all failures within critical facilities these days are due to human error. So one of the biggest things that you can do is to train your folks on how to operate the facility and how to maintain the facility. So again, training is typically specified within the divisional specs of a bid package. So if you can get someone to put their arms around the training and define the instructor qualifications, what shifts, most of these facilities will have 3 or 4 shifts. So how am I going to train the 3 or 4 shifts? What are the certifications of the training folks? Are there OSHA, personal protective equipment elements, arc flash? So I think that you have a great opportunity to specify what that training program is and customize that training program specifically for your facility. Another area where we were talking about the O&M manuals, you really need to, as part of the planning, define what operations and maintenance requirements you need for your site infrastructure. And you need to be able to differentiate between what operations tasks are and what maintenance tasks are, because they're not the same thing. And then you need to look through the list of tasks and requisite skill sets. What do I need in order to run this facility? And put together job descriptions for both the operations and maintenance side, and then go out and seek the tasks that you need to staff that facility. And then the other thing that I think you need to do is to look at critical work versus non-critical work. Certainly the work authorization process for critical work within a facility has a much different escalation process, a much different approval process than doing non-critical work, and you may not need the same skill sets to do both. We talked a little bit here, are you going to, when you look at your facility, are you going to combine your operations and maintenance folks into one group, or are you going to have a separate operations and maintenance task? When you go out and look to hire folks, are you going to look for the jack of all trades? You can go out and hire guys, Navy nukes that ran reactors on a sub or a carrier. Well, those guys know controls, they know mechanical, they know electrical, they know turbines, they know steam. Or are you going to go out and hire trade-specific skills, mechanically, electrically, and controls? That's a different philosophical approach. Are you going to use 24/7 coverage day one? Or are you going to try and cover the facility during normal business hours with an O&M staff, and then have some sort of on-call agreement with one of your vendors to support you on weekends and non-day hours? And then how are you going to staff each position? Are you going to go out and hire employees directly? Are you going to use in-house contractors? Or are you going to use a combination of both? And I would certainly advocate that when you go out into the global marketplace, it's even more important that you understand what resources are available out there, whether it's direct employees, and what support you can get to satisfy this 24/7 coverage or whatever that combination or configuration is. And then when you look at your organizational structure, certainly if you're thinking domestically and deploying globally, then you're going to have an enterprise level operations and maintenance organization. And then you have to make a determination on how you're going to incorporate your site facilities team, and how are those folks going to communicate back up to that enterprise level organization in the U.S.? Operations shift coverage. Can you support some of your shift requirements by having monitoring done in the U.S. at your network operations center here? And again, looking at your maintenance now, and you look at the trades, electrical, mechanical, monitoring, and controls, what vendor support and contractor support is available in the geographic region where you're going to put that data center? The work authorization process in any critical facility, certainly Bank of America, IBM, and others do a wonderful job. They have a very, very rigorous approval process to do work authorizations. So who's involved, what's the approval process, what are the prerequisites, who are the staff, when's it going to occur, what's the purpose. It's very, very detailed. You've got to be able to extend that culture out to your global site. You've got to be able to look at your operations and define what your performance indicators are. Right? What metrics am I going to measure whether my guys are doing a good job at operations or a bad job? And then, you know, again, when you look at critical versus non-critical, you can probably do dry runs on some of your non-critical stuff. I don't think that you could do live practice runs with your critical loads. Are you going to use double verification when you go out and do a work routine? How are you monitoring your valve and switch positions up in the network operations center or the control room? Who's handling your lockout, tagout, and safety programs? All of these things have to be considerations within that work authorization process. Pretty much covered this one. When you put together your operations and maintenance procedures, people are pretty good at developing their MOPs and SOPs for the operations side of the house. I would advocate that you need to take the same measures now as it relates to the maintenance side. This is really a philosophical approach on how you want to have those operating procedures. I have some folks that say, hey, I'd like a photograph of my switch gear and I'd like an arrow right here when it says push button A. There's an arrow that says button A. I have other people that say if my guy can't find button A, he shouldn't work for me. Right, so, and then what's your contingency if you're in the middle of a work routine and the response that you get in the field is not what your predicted response was? I got a problem, so what's my back out procedure? And then this is one that seems to bite even our smartest clients. You've got to make sure that after you do a work routine, that you restore the systems to normal operating status. We've had calls where people have said, hey, I had a utility outage and my generators didn't start. And you go to the site and you find out that they did an oil change on all the engines and they left all the engines in manual. Right? So they didn't go back and restore the system to normal operating status, and so that failure caused a major outage. This is another one where I think you can help. Most of the facilities today have a computerized maintenance management system. You can, during the planning size segment and the specs, if you define what information is required to feed the CMMS, that a lot of the information that the commissioning agent gathers, equipment lists, et cetera, you can get them in an electronic format, whether it's Excel is importable into most CMMS systems. So if you define that up front, that's a gimme putt. If you wait till the end, you've got to hire somebody to go in and gather all that information. So this is another thing where I think in your upfront planning, you can feed into your CMMS system as part of the beginning. And then you also have to define philosophically what type of maintenance program are you going to run. Are you going to run a corrective program where you run your equipment to failure and you fix the piece of equipment after it breaks? Are you going to use a preventive maintenance program where you, at some periodicity and frequency or based on run hours, you go out and do a prescribed maintenance routine on the equipment? Or are you going to use predictive maintenance, where you say, okay, I'm going to use vibration analysis and thermography and tribology to analyze the fluids, et cetera, to try and predict when you're going to have an equipment failure and perform your maintenance on that basis. And then use your building automation systems to create histories and to do trending, and also use these maintenance rotations as an opportunity to build a database on how your equipment behaves, and if you have a large portfolio, compare those equipment lists, right, to compare the data and try and predict how your equipment's going to behave. We talked pretty much about the maintenance procedures, but I will say that they've got to be specific. You do need to determine, you have some things that require daily, weekly, quarterly, annual maintenance. The procedure for those are not necessarily the same. So it's not a one-size-fits-all, so you need to take a look at that. And then another element that is becoming fairly common within our industry is to have BIM modeling done during design. So think about how that's going to be incorporated into your overall operations and maintenance program, if it is, and trying to find those parameters during the design cycle. Last but not least, you have to have a way, now you've designed it, you've constructed, you've figured out how you're going to operate it, you figure out how you're going to maintain it. How do you know that that facility in Bangladesh or Brussels or in Dallas or in any other location is actually performing? So one of the things that we do for a lot of our clients, and this is fairly common for IBM, I'll talk about a little bit about what they do. They do facility audits, and they do an annual review of the operations team, and they do an annual review of the MEP infrastructure. So to give you a little insight, and this is to go back and validate that what was designed, constructed, and commissioned is still reliable. And do you have any potential faults out there? You try and catch them before you have a catastrophic failure. So what these facility estimates are audits put together are really to identify any potential reliability exposures you have within the facility. Are you running into any concurrent maintenance issues? Something I talked about earlier. And from a capacity standpoint, are there any pinch points, right? Am I exceeding my N+1 capacity? Do I not have enough cooling capacity on the data center floor? It gives you an opportunity to review the sequences of operations and make sure that that control package is working the way, and that as you've been gone for a year, everybody didn't take everything out of auto and put it in hand and decide to run it because that was easier. And then taking a look at your monitoring alarms and systems to ensure that they're optimized so that your operations staff is fully aware of alarm notifications. Sometimes I find it mind-boggling to go in an network operations center and you'll find a list of 100 alarms in there that someone hasn't gone in and looked at, or they'll just go in and clear them as a group. So the audit program will look at that kind of thing. And there we go. And the audit, we typically look at the building envelope, the roofing system. Somebody was talking about earlier, we were talking about roofs, and he had a statement that said, well, it needs a new roof. All right, so you need to put some definition and clarity around here, but we typically will look at the building envelope, the roof, the structure, the access points to make sure that all those elements, the security systems, all those elements are in place and still operating the way they were. Taking a look at site vulnerabilities. Now, obviously, this may apply to a facility that you acquired. All right? You may not necessarily build a facility next to a highway or a nuclear power plant or some other hazardous area, but you may assume a facility and you'll want to identify these elements if they're a problem. And then what we do in the case of IBM in their Tier 3 and Tier 4 facilities, we have a very well-defined list of building elements, both electrical, mechanical, and controls. And this is Tier 1, Tier 2, Tier 3, and Tier 4. And it's a very, very simple audit. We review the facility. The requirement, you either meet it or you don't. There's very little gray, but the red areas are where you did not meet the Tier 3 requirement. The green are where the requirement was met. And then the yellow is indicative of it met it, but there was some sort of peculiarity that needed to be resolved. But I'll give you an example that this one here is the generator system includes a redundant generator. Well, that's not a requirement in Tier 1 or Tier 2. They met it here, but on this particular one, the generator system has all of the redundant appurtenances. Well, these guys want dual starters, dual filters, a whole bunch of other elements. So although they had the redundant generator, it didn't necessarily have all of the redundant elements on the generator. So that's a typical for what we would do electrically. Mechanically, it's the same thing. We would go in and here's one up here, filtration level of outdoor air equal to MERV 13 per ASHRAE 52.2. Well, that may not be that critical in Dallas, Texas, but that would sure be critical in Beijing where you have terrible air quality. So again, that's one of those elements. But we'll go through here, identify the elements that don't meet it mechanically, electrically, and then we look at it from an operations perspective. Is the documented commissioning and recommissioning test plan in place? Is there an established operator training program? Remember we said there was 74% of the failures. What's your emergency response procedure? So there's a whole list of operational elements also included in this audit. The result of that, we rank them based on probability of occurrence, the impact to the critical load, and then put together a budgetary estimate on what it will be to reinforce that element. That usually goes into a site exposure summary that looks at the probability of occurrence, the impact on the load, and then a budget so somebody can prioritize those reinforcements, and then it comes out in a report. So this is pretty typical for what an audit program would be. And then moving to the end, a couple of the takeaways here, just remember to try and incorporate as much of your operations and maintenance into the design phase. Specify your operations and maintenance elements into the project bid documents. Conduct operations and maintenance training during your third-party commissioning if possible, and incorporate those transitional services into the project bid docs. And implement a continuous training program, have a rigorous operations audit program, and have a rigorous MEP audit program. Thank you.